Hello and welcome to a new video. This is for Precalculus, this is lesson 4, and we're going to solve for unknown things in a triangle. We're going to use the skills that we've already gained in our previous lessons, although I did skip over lesson 3 because lesson 3, this is for Math UC Precalculus. Lesson 3 has us using trig tables to find things, and that's not a thing that we do anymore. I actually have never in my life used a trig table. I have plans to use a trig table for a YouTube video just to see what it's like, but that hasn't happened yet. Also, if you would like to download a notes page to fill in while you're watching this, then you can click the link in the description, or maybe it'll appear somewhere up in the corner as I'm saying it. And I do have a cold sort of thing, so my voice is a little hoarse, so sorry about that. But here we go, solve for triangle unknowns. So the main thing that we will need for this lesson is to remember about sine, cosine, and tangent, and which sides of our triangle go with them. So we did that in lesson 1, I believe it was. We talked about sine, cosine, and tangent, and we made their ratios. And I guess we also did that in lesson 2, but we did it with all 6 trig functions. So now what's going to happen though is we're actually going to do a problem that we could conceivably need to do in real life, which is we know 2 of the pieces to one of these equations, and so that means we can solve for the 3rd piece. So we are going to know the angle and one of the sides of the triangle, and we're going to be asked to find the other side. And so it's still going to be super helpful for us to remember our acronym, so TOA, so that once we know which sides are being referenced, we can then pick the trig function that's correct. And by the way, you will need a calculator for this. I'm going to be showing you how to use the TI-84, although you can also use Desmos, which is an online graphing calculator and also has an app for your phone. Desmos is free and is awesome. TI-84 is not free and is also awesome. If you don't have a calculator and you want to get one, you can check out the link in the description below. If you do buy a TI-84 calculator from Amazon, from that link, not only will you have a really cool calculator, but I think I get like money because you bought it off of my link. But no pressure. Okay, let's keep going. Trig functions. All right, so here's what our problems are all going to look like. We have a triangle. We know that it's a right triangle, and we know one of the angles, and that means we could find the other angle if we so desired. We don't have to, but we could. And then we can see that one of our sides is labeled with a number and one of our sides is labeled with a letter. Now, this letter A that it's labeled with is not necessarily referring to the idea of the Pythagorean theorem, although it kind of works out in this situation. That side could be A, but just consider these to be generic labels that we just want a variable. So here we go. We look at where our angle is, right over here, and then we say, okay, what sides are being talked about? So this A over here, this is the opposite side. And this 21 down at the bottom, that's the adjacent side. And then we say, okay, which trig function goes with opposite and adjacent? The correct answer, tangent. So the way we set this up is we're going to say tan, or tangent, of 18 degrees equals, and then it does matter which one we put on top, just like it did before. Opposite goes on top, so I put A on top. And then the adjacent side, 21, goes on bottom. And now we're going to solve this for A. Now, you can go ahead and find tangent of 18 first and then decide to keep solving the equation. But I like to wait to put things in the calculator to the last possible moment to avoid rounding unnecessarily. So I'm going to do times 21 to get that 21 off the bottom of that fraction. So kind of like timesing by 21 over 1, for instance. And then I do it on this side as well. And that gets rid of the 21 on bottom, so that now I have A equals whatever 21 times tangent of 18 is. You can also use your phone calculator for this, although there is a specific order. I'm thinking in particular of the iPhone. There is a certain set of things you need to do to get your iPhone to do it, or your phone to do it correctly. So the easiest way to do it is probably actually to type it in on Desmos. Second easiest, and since we have a calculator, most likely, is to put it into our graphing calculator. So one of the things that we need to do with this, though, no matter the calculator we're using, is we need to know that we're in degree mode, because this angle said 18 degrees. If you go to mode and you go down to where it says radian in degree, we're going to do radians this year in Precalculus, but not yet. Right now we're still in degrees. And so if your calculator is brand new, it might be in radian mode because no one's ever changed it. Or if it is a hand-me-down, it might be in radians because that's what the last person used. We need it to be in degree mode. So I press enter and then clear. And now mine says degree up here. If you have an older style TI calculator, it may not say it up at the top. Now I'm going to do 21 times 10 and 18. And I don't need to put the degree symbol because the calculator knows anything inside of this is meant to be a degree because it's in degree mode. So I press enter, and my answer is this nice long number. So this does not specify what we need to round to. So I'm telling you right now, if something doesn't specify what to round to and you're in Precalculus or above, you should round to at least 2, maybe 3 decimal places. So I'm going to round to 3 here. 6.823 is my answer. 6.823. 823. There are no units given to me for this 21, so I do not need to put units either. Side A is 6.823. Okay, so that's the process we go through. Let's do another example. There is one other tricky thing that can happen, and it may be that this is still review from geometry, depending on what you did in geometry. So if it is, that's great. Just hang with me for a little bit longer until you're sure you're comfortable with how to do this. Okay, on example 2, same instructions, solve for the unknown, new triangle, different angle, different side length, and so let's figure out what sides are being talked about here. This B is across from a right angle, so it is the hypotenuse. Notice this is not B as in the Pythagorean theorem, because in the Pythagorean theorem, the hypotenuse is C. And then right here, this 11 is our adjacent side, because it is next to 50 degrees. So which trig function uses the adjacent side and the hypotenuse? That would be cosine. So cos 50 equals, adjacent goes on top, so we've got 11 over b. Now, the way we solve this takes a little bit more effort, but is still not too terrible. Because in order for us to get b by itself, it first needs to be not on the bottom of this fraction. And you can think about this first step in one of 2 ways. You can think, I'm going to times both sides by b over 1, like what we did before. Okay, that's one option. Cancels out the b's, and then we're ready to go from there. Or, I'm going to show you the other way that we can think of this. The other way is this thing called cross-multiplying, which you usually learn in Algebra 1 and then revisit in Algebra 2. If you have a fraction on both sides of an equation, which I do because I put the left side over 1, I can do the top of the left times the bottom of the right equals the bottom of the left times the top of the right. Whichever way you do it, so if you times b on both sides or if you cross multiply, our next step is b times cosine 50 equals 11. Now you may be thinking, well, b is still not by itself, so I don't see how that helped us. It helped us because now we can just divide this cosine 50 degrees over to the other side. Now that might seem tricky. Remember that cosine of 50 degrees is a number. We haven't found it yet, but we could. So just like if this was b times 2, we'd divide by the 2. Since it's b times cosine 50, I'm going to divide by cosine of 50. And that means that on my calculator, I'm going to do 11 divided by cosine 50, and that'll be my answer. I've already forgotten the numbers. 11 cosine 50. 11 divided by cosine 50. We're still in degree mode, so that's great. My answer is 17.113. B equals 17.113. Example 3. Solve for the unknown value again. So just, more of the same. No big deal. We have an angle down here, 73 degrees. It looks like 15.2 then would be the opposite side. And C over here would be the hypotenuse. So opposite and hypotenuse is good old sine. Sine of 73 degrees equals 15.2 over C. So I did this on purpose. I think that the times when the variables on the bottom are quite a bit harder than when it's on the top, because when it's on the top you just multiply and you're good to go. But when C is on the bottom like this is where we need to think about cross multiplying or multiplying by C on both sides first and then dividing by the sine 73 degrees. Now you can, if you want, just memorize this process and say, okay, if the variable is on top, it means I multiply. If the variable is on bottom, I divide. But it does matter when we divide that we put the sign of whatever on a second. Because see how this order here is happening? It is not the same to do sine 73 divided by 15.2. If you don't believe me, try it. But it does matter that we put that 15.2 first. So I like to be safe and just go ahead and write it out and do it. But you know what? To each their own. 15.2 divided by sine of 73 degrees. And did you know you don't actually have to close the parentheses at the end as long as they're the last thing that you needed to type? Fun facts, 15.895 is our answer. 15.895. 15.895. I have a hard time remembering numbers between when I switch windows, so that's why. Okay, so this is all there is to it, really. So I've got a now you try, where there's 3 triangles, and you can try it on your own. Or if you are part of my math class that's doing Precalc Math UC, you're welcome to go ahead and check out the homework. I do want us to do another lesson this same week because I think this was pretty easy and straightforward. I think the next lesson is pretty easy and straightforward. And by combining them into the same week, we will end up having more time later on in the semester, which is great. All right, now you try. It is so important in math that you try problems in such a way that you can know if you're doing it right. And so here's your opportunity to pause the video, start it back up either when you get an answer or when you get stuck, and hopefully either way you'll know whether you're doing it right or wrong and know how to keep going. But pause the video and then start it back up and we'll do this together. Welcome back. So over here on the left, we're going to start with this triangle. We've got 43 degrees. D is our adjacent side, 10 is our hypotenuse, so that means we're going to use cosine. Cosine of 43 degrees equals D over 10, which means I need to multiply by 10 on both sides, or you can think about it like it's cross multiplying. That's totally what is happening here. D equals, let's do 10 cosine 43. 10 times cosine 43. I don't think I need to actually type times there, by the way. 7.314 is my answer. And then I'm going to do this middle one. So if you got stuck on the first one, go ahead and pause the video and see if you can make more progress on the second one. Let's see, this is our adjacent side up here, and this is our opposite side. So adjacent and opposite gives us tangent. And if you're like, how do you know that? I'm using SOHCAHTOA. So this is the OA of TOA, which is tangent. So tangent of 24 degrees equals 7.2 over E. So we times both sides by E to get it off the bottom of our fraction. And then that's an interesting E. And then we divide by tan 24. And if you are lazy, aka a budding mathematician, because mathematicians are lazy, we could do kind of a weird way of showing our work like this. We're like, oh, I'm going to divide both sides by tangent of 24 and save ourselves some writing, even though that is not really a super great way to write this out. 7.2 divided by tangent of 24. 7.2 divided by tangent of, what was it, 24? 24. Okay, 16.171. 16.171. If you got stuck on the second one, now's your chance to see if you've learned something. Check out, try to pause the video and do the third one here. Okay. All right, we've got f that we're looking for, which is the opposite side. 22 is our hypotenuse, and that means we're going to use sine, because that's the O of so katawa. So sine of 72 degrees equals opposite over hypotenuse, so f over 22. So I'm going to times both sides by 22, and then put it in my calculator. F equals 22 sine 72. 22 times sine 72. 20.923. Now, if your issue here was that you did not get the same numbers as me, even though you think you typed it in the calculator correctly, one of two things could have happened. One, you might be in radian mode, make sure you're in degree mode. Two, if you're using a calculator other than a TI calculator, like your phone, you may just be putting it in wrong. So just really quickly, so that you know, in order to do this on our phone, we'd have to type in the angle and then choose the correct trig function and then times by whatever. And so on the ones like this middle one where we're dividing, actually gets tricky to do on the phone. You'd have to do, you type 24 and then tangent, and you actually need to write down that number, so you can do 7.2 divided by that number. Because if you take the answer to tangent 24 and divide by 7.2, that's not the right order. So that's why your normal phone calculator, while it's great, is not always the best tool for the job. If you're using your phone anyway, download Desmos, which is a really awesome graphing calculator app and is free. So that will help you out, and it's really easy to use. Thanks for watching. If you like this video, there's a cool way you can show that. You can press the thumbs up button, which also is a universal signifier, I think, at least, of that you like something or that you're hitchhiking. But in this case, I think it'd be obvious that it's that you're liking the video. Although maybe you're using the video to hitchhike with me through math or something. I don't know. But thanks for watching. You can check out my website, which is up above my head, for more resources. And I look forward to seeing you in the next video.